In this lesson, we're going to introduce the idea of graphing a log. One of the biggest things about logs that you have to remember is that logs are inverses of exponentials. So an exponential growth looks something like this, and it has a horizontal asymptote. And if you remember, inverses reflect over this 45. So if you describe an exponential, it has very, very slow growth, and then at some point it starts to pick up speed, and then it has very, very fast growth. So the exact opposite of that would be the log. So instead of it having very, very slow growth, it has very, very fast growth, leveling off to very, very, very slow growth. So exactly the opposite of whatever an exponential would be. So this is a log, the inverse of an exponential growth. And then if you have a decay, it has pretty quick growth leveling off, but going down. And then a log is kind of weird, that it would drop down really fast and then kind of start to level off. This one isn't anywhere close to as often as this. It's all about the base on here, that if your base on your log is greater than 1, then it's going to look like this. If it's less than 1, then it's going to look like this. So it just doesn't happen very often. So most of the time your log is going to look something like this. You have these domains and ranges. So remember that an exponential has a horizontal asymptote, and if you reflect that along this 45, it will now become a vertical asymptote. So every single log is going to have a vertical asymptote, so you'll have a domain issue for sure. You can't log 0 and you can't log negatives, so that's why your domain is going to go from 0 to infinity, not including 0. Where an exponential goes up, goes left and right forever, but it doesn't go up and down forever. So it kind of has a range issue. So an inverse switches all your x's and y's, so a range issue on an exponential becomes a domain issue on a log. And then the range, or the domain of the exponential is negative infinity to infinity, so the domain of this becomes the range of this. So negative infinity to infinity goes up and down forever. Starting point is 1, 0. It can be shifted for sure, but just like when you graph a quadratic and everything, every graph of these types of things have starting points, typically 0, 0, but a log starts with a 1, 0 because it's the inverse of your basic exponential. An exponential has a 0, 1. So if you do the basic idea of an inverse, you're going to switch that coordinate, and when you switch that coordinate, it becomes that. All right, so vertical asymptote at 0. So that's the basic idea. Let's look at a couple of them real quick. So just like all of your other graphs in the past, you have this potential vertical stretch or compression, and if it's negative, then you could potentially have a reflection on that. This is going to be your left and right shift, so horizontal shifts, and don't forget it's always in an opposite direction. And then this is going to be your up and down shifts, your vertical shifts, and that's totally normal. All right, so your vertical asymptote is always going to be based off of your shift here. So normally your your vertical asymptote is at 0, x equals 0, and dependent upon whatever kind of shift that thing has. And then because of the horizontal, the vertical asymptote, it's going to shift your domain. But the range always goes up and down forever. And our starting point is 1, 0. So here is our log equation. We're starting at 1, 0, and we're going to shift down 5. Okay, so we have a vertical asymptote that is not shifting left or right, so that's going to stay. And then we're starting at a 1, 0, but it got shifted down 5. 1, 2, 3, 4, 5. And so that's just kind of a quick, rough sketch of that log. Our domain is going to be from 0 to infinity. All right, and then our range is always negative infinity to infinity. And then our vertical asymptote is x equals 0. All right, if we do this one, we're starting at a 1, 0. However, it's going to shift left 2. So our asymptote would have been here, but it is shifting left 2. Our starting point would have been here, but it's shifting left 2. And just doing a quick sketch of that. So our domain is now from -2 to infinity. Our range is still -infinity, infinity. Our vertical asymptote is going to match our domain at x equaling -2. All right, so this one has a couple different things. So we're starting at a 1, 0. We have a vertical reflection. So that means our normal graph that would have done this is going to get reflected and do that. Okay, it's going to be vertically reflected. So we'll have to take care of that, but let's do all of our shifts before we reflect it. So we're going to shift right 3, which is going to be our asymptote, and we're going to shift up 4. Okay, so we start at 1, 0, 1, 2, 3, 1, 2, 3, 4. We have a vertical asymptote at x equaling 3. And then instead of our graph doing this, it got vertically reflected. So it does that. So our range is always -infinity, infinity. Our domain is from our asymptote on, so from 3 to infinity. All right, and that was just some quick basic sketches of some logs and different kinds of transformations that can be applied.